Warning: the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is dedicated to a review for college algebra students of relations and functions. It is assumed that you've actually seen all this stuff before. This is just a brief review going through some of the definitions and kind of the stuff that's involved with relations and functions. So let's go ahead and get started. Relations, domains, and ranges. A relation between two sets of objects is a collection of ordered pairs containing one object from each set. If the object X is from the first set and the object Y is from the second set, then the objects are said to be related if the ordered pair X, Y is in the relation. The set consisting of the first components of each ordered pair is called the domain, and the set consisting of the second components of each ordered pair is called the range. Now that's a very, very strict definition. Let's go ahead and visualize this. You have a bucket of objects in this black circle, and it actually doesn't matter what those objects are. I'll just kind of list them out. Let's pretend that you just have 5 objects in that bucket, and there's a relationship, some type of weird statement that glues together the objects in this black bucket to some objects in the red bucket. Let me go ahead and list out some objects in this red bucket. Notice that I don't actually need the buckets to have the same number of objects. Now I'm going to create a relation between the objects in the first bucket and the objects in the second bucket. For example, that just means that X sub 1, that object here in the first bucket, leads to Y sub 1, or is tied somehow to Y sub 1 in the second bucket. X sub 2 is somehow related to Y sub 3. X sub 3 is somehow related to Y sub 2. X sub 4 is related to Y sub 1, and let's go ahead and say X sub 5 is also related to Y sub 1. This is a relation tying together objects in that black bucket to objects in the red bucket. The set of objects in the black bucket is called the domain of the relation, and the set of objects in the red bucket is called the range of the relation. And each of these relations creates what we call an ordered pair. So there's an ordered pair called x1, y1 because x1 and y1 are related. But there's also an ordered pair called x sub 4, y sub 1 because x sub 4 is related to y sub 1. There is not an ordered pair of the form x sub 3, y sub 1. And that is because x sub 3 does not go to y sub 1, it goes all the way over to y sub 2. So that's the basic idea behind a relation between objects in one group to objects in another group. We're going to further define some qualities of relations. Each value in the domain is known as an input or an independent variable, and each value in the range is known as an output or a dependent variable. Let's go ahead and hop back to our previous mapping here. That's what we'd call this, a mapping. And this black set, which we were calling the domain, consists of a bunch of objects, x1 through x sub 5. It doesn't have to just contain 5, it could contain a bunch of them. But each of these is known as an input. And in general, the input variable x is called the independent variable. And in this bucket, the red bucket, which we're calling the range, each of these y values is an output for a corresponding input. And these are also known as dependent variables for the simple reason that they depend upon what you're plugging in to the domain. So if I plug in x1, then we get out a y1. The output completely depends upon what we plug in as an input. Now let's actually refine our definition even further by starting to put in some conditions. A function is a very special type of relation in which each possible input value leads to exactly one output value. Now this is so important that I'm going to redraw something here. So we're going to create a relation between these two sets. One will be our domain, the other will be our range. Let's pretend that x sub 1 here leads to or is related to y sub 1. And x sub 2, it leads to y sub 1 as well, or in other words, x sub 2 is related to y sub 1. Let's also say that x sub 3 is related to y sub 2. Because each input leads to exactly one output, then this is also known as a function. So this is a function because each input leads to only one output. X sub 1 only leads to one value in an output, which is y sub 1. It can be the case that another input, a completely different input, in this case x sub 2, that could lead to the same exact output. That's totally fine. What we're more concerned with is that x sub 2 does not lead to two different outputs. So as we've written this here, this is a function. However, this guy right here, this is not a function. And the reason why is because the input of x sub 2 leads all the way over to two completely different outputs. So the single input of x sub 2 happens to lead to both y sub 1 and y sub 2. That's a problem. So again, just to repeat, this is not a function because x sub 2 leads to two different outputs. So a function's a very restricted relation, one that we really want in mathematics, where each input leads to exactly one output, not more than one output. My little warning here is very important to heed. Students often think this means that an output can only be related to a single input for the relation to be a function, but that's not true. The only condition that a function needs is that each input leads to a single output. But a single output can actually come from more than one input. That's totally fine. This is called a mapping relation, what you see here, but a lot of students will see functions in tables. For example, you will often see a tabular function like this, where it is assumed that the left column represents the input and the right column represents the output. Again, recall, the input is called the independent variable and the output is called the dependent variable. And that's mainly because the output, what you get out of a function or relation, depends upon what you plug in. Notice 3 leads only to 1, 2 leads only to -8, 4 leads only to 5, and 7 leads only to 5. This is a function because each of those inputs leads to a single output. I'm not concerned about repeated outputs. I'm only concerned about repeated inputs leading to different outputs. In the second example, or the second table, again, the leftmost column is the list of independent, or represents the independent variable. The rightmost column represents the dependent variable. Notice 3 leads to 1, 2 leads to -8, 4 leads to 5, and 3 leads to 7. There's a problem there though. This is telling us that 3 leads to both 1 and to 7. This means that you have an input that leads to two different outputs. This is not a function. Now, normally during a review, I wouldn't take so much time and detail into a topic like this because it's assumed that you've seen this and you've attained a level of proficiency with this to where you wouldn't have to have this review. But this material is so important for your success in this math course, whatever math course you're currently in, and your future math courses. Now, it is often the case that you have to determine if a relationship between two variables represents a function or not. So let's suppose we've been given some type of relationship between two quantities, and we need to determine whether the relationship is a function or not. The first thing you're going to do is identify the input values, basically identify the independent variable, and then identify the dependent variable. That's usually pretty obvious, but there are times when it can be somewhat elusive. If each input value leads to only one output value, then that relationship is a function. If, on the other hand, any input value leads to more than one output value, then that is not a function. That's pretty much it. Let's just try this with a word problem or an application or a conceptual problem here. Is your student ID or student ID in general a function of a student's name? Now, I need to talk to you about this language, a function of. What does that mean? You will often hear this in mathematics as, is y a function of x? When you see the words a function of or is something a function of, that really means that the something, which in this case is the student ID, is the dependent variable, in other words, the output, and the phrase or the words that follow the words a function of is going to represent your independent variable or your input. So when somebody says, is y a function of x, they really intend that x is the input and y is the output. That's probably one of the most important statements that you could try to memorize here, at least at this level of mathematics. Most of mathematics is incredibly logical and deductive. So if you happen to know, like for example, one or two theorems, you can build onto those theorems extra information called lemmas or theorems or corollaries. However, with definitions or definitional language, like is this a function of that, it takes a little more memorization. You do have to understand the pattern of the language. So when I ask you, is student ID a function of a student's name, you should start thinking about inputs being students' names. So let's go ahead and think about inputs versus outputs right now. The inputs being student names and the outputs being student ID. I actually like to do this as a table just because, well, it works really nicely that way. And you can list out some names. So there are 3 names right there of students, and the outputs should be their student IDs. So let's just pretend the student ID for John Doe there is 0001, student ID for Jane Doe is 0002, and the student ID for Ima student is 0003. Is that a function? In other words, does each input lead to a single output? Well, it looks like it does, right? However, it could be the case that at your college, there's more than one John Doe. And if there is another John Doe, that John Doe is not going to have the same student ID as the first one. So this John Doe might have a student ID of 0057. And now we have a problem. We have 2 John Does as inputs, but they lead to completely different outputs. And because of that, this is not a function. Again, it's because I could tell you very honestly, as an instructor, I commonly have students with the same names in the same class, but they will not have the same student ID because, well, that's their student record. You can't have 2 different students have the same student record. That would be, well, against the law, actually. So this is definitely not a function. But the second part says, how about the reverse? What if I asked, is a student's name a function of student ID? Now remember, that language means that the back end, this piece right here, is your input variable, and the front end is your output variable. So our input being student ID, leading to the output of student name. Let's go ahead and write some of these down. I'm just going to copy from the previous table. All right, there we have that. Now let's think about this logically. If I give you a student ID, is it going to lead to 2 completely different names? The answer to that is no. You give somebody you look up a student ID of 0001, and that's going to lead only to one person. The student ID of 0002 is going to lead to only one person. Student ID of 0003, one person. And this last student ID leads to only one person, a completely different person actually than the original John Doe. However, you might, if you're just looking at this as a set of data, you might say, oh look, 0001 leads to John Doe, but guess what else leads to John Doe? 0057. Well, guess what? That's totally okay. That's absolutely fine that you have two student IDs leading to the same name, because that can totally happen. But the reality is, a specific student ID like 0057 is not going to go to two different people. That can't happen. That would be weird. If you think about your student ID at your college campus, it's not going to represent your record and somebody else's record. It's not going to do that. It's a function. It only represents your record. Your name might be the same as somebody else's at your campus. That's perfectly fine. But you actually have two completely different records. So anyhow, this is a function here. Student name is a function of student ID. You may say, but I go by two different names. But there's only one that gets listed officially, at least in your campus system. Now, there is a bit of a rabbit hole with language examples like this. You could often find counterexamples, and that's just because you're hunting really hard for them. Well, what if I change my name? Something like that, right? So those are very special edge cases. Let's not concern ourselves with those. Now, I want to let you know, this was an example I was going to do, but we actually did this example earlier, so I'm skipping it. And I'm doing that so I can get to this example, because this is actually the most relevant example. Determine whether the relation represents y as a function of x. Remember what that language means. Y is now supposed to be our output variable, and x is supposed to be our input variable. So what we need to know is, if we plug in a value of x, do we only get one value of y out for this specific relation? Well, maybe. For example, and by the way, this is much easier to deal with if you just write it as a table. So some people will try, unfortunately, a number like 3. So if I were to plug 3 in for x and square it, it becomes 9, and 9 minus 9 is 0. And so we have the square root of 0, which is 0, and plus or minus 0 is 0. So far, it looks like when I plug 3 in, I get one output. And actually, if you plug negative 3 in, you'll also get one output. But when you plug in the number, let's say 0. If I plug in the number 0, I will get plus or minus the square root of 9 minus 0 squared, or in other words, plus or minus the square root of 9, or in other words, plus or minus 3. Notice the input of 0 leads to positive 3 and also leads to the output of negative 3. That is not a function. Again, the input of 0 leads both to positive 3 and simultaneously to negative 3. And that means because that input of 0 leads to two completely different outputs, this is not a function. This is actually a good example because you just need one counterexample, one thing that breaks the system to showcase that your relation is not a function. You just need one place where it doesn't work, and then you immediately know it's not a function. All right, this is the end of the kind of introductory review video for relations and functions. In the next video, we'll begin to evaluate functions using function notation. I hope to see you there.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.